Now, part 2 of your experiment is going to use unknown sample number 1. What this tells you to do is get the mass of your 2 small beakers. In our case, we have our medium-sized beaker and our small beaker, 150 milliliters and 100 milliliters respectively. We're going to record the mass of both of these beakers completely empty. Once we've done that, we'll use unknown number 1 and transfer approximately 2 grams into beaker number 1. Whichever you designate as beaker number 1 doesn't really matter, just be consistent and know which one is which. So we're going to transfer 2 grams of this mixture into 1 beaker. So I'm going to do that. I've got my 2 grams, or approximately 2 grams of this mixture in beaker number 1. Now, after that, you're told to get beaker number 1, record the exact mass. Our scales go to 2 decimal places, so that will get, 2 numbers beyond the decimal. Then what we're going to do is we're going to put our magnet at the bottom of this. So what this is illustrating is what's known as a physical separation. We have a magnet, we have steel beads that are attracted to this magnet. Now, once I do that, I'm going to hold my magnet to the bottom of this mixture, and I'm going to transfer all of my sand to my other beaker. So I've separated these 2 things. I've separated the sand from my beads. Now, it's important that whenever you're getting your fraction of unknown number 1, that you make sure that this mixture is fully, is pretty evenly distributed, pretty evenly mixed, because these steel beads, they will have a tendency to sink to the bottom. So after we've done that, I'm going to repeat this a total of 2 more times. What is the mass of sand and what is the mass of steel beads that is in this approximate 2 grams? Is it 2 grams exactly of sand, therefore 0 grams of steel beads? No, it's not. But that gives me a way of calculating an approximate ratio for this mixture.